So in this video, we'll be going over the product rule. So what is the product rule? Well, if we have some function in the form of g of x times h of x, then if we were to differentiate this using the product rule, that would just be g of x times h dash x plus g dash x times h of x. So what does that mean? Well, if we look at this example now I'm going to do, so if we look at the example of, let's say we have f of x is x squared, and that is all times by the square root of 3x minus 1, okay? So in this case, if we can make g of x be x squared, and then we can make h of x, that will equal that square root of 3x minus 1. In this case, I'll write that as 3x minus 1 to the power of a half, okay? And then what we need to do, if we want to differentiate this using the product rule, then all we need to do is just differentiate g of x and then differentiate h of x first. If we do that, I'll scroll up. If we do that, we get g dash x. Well, that would just be 2x, right? We'll just differentiate x squared. And then with the h dash x, if we differentiate hx, well then that 3 would come out of the brackets. We get a 3 coming out of the brackets. And then we also need to times by that half. So we would get a 3 over 2. And then we still have our brackets of 3x minus 1. And then we need to now put the power down by 1. So that will be minus a half. So now what we can do is we can do g of x times h dash x. So that would be the x squared times by the 3 over 2 and the 3x minus 1 to the power of minus half. If we do that, we would get a, so f dash x, that would equal a 3 over 2 x squared, and then in brackets would have the 3x minus 1 to the power of half. And then for the other one, it would just be g dash x times h of x, so that would be a 2x, and then in brackets a 3x minus 1 to the half. And now we can just put all these together over one single fraction. So how would we do that? First things first, let's rewrite that fraction where we have the power of minus half. Let's bring it down to the bottom. So if we did that, we would get a 3x squared, and that would be divided by 2, and then just a 3x minus 1 to the half, and that is plus 2x, and that would also be a 3x minus 1 to the power of a half. And now all we need to do is we have this. Now if we can just, now we do have a denominator on the left fraction, okay? We just need to times that right number by 2 times 3x minus 1 to the power of a half. So if we were to do that, we would get a 3x squared, and that would be plus a 2, so we're going to times everything, 3x minus 1 to the half, and that will be times by the 2x, and then the 3x minus 1 to a half. Okay, and now this will all be over that 3x minus 1 to the power of a half. And now it's pretty simple from here. We can just expand and simplify out. So if we do that, therefore we get the 3x squared. We'll get, let's start with the 2 and then the 2x. So 2 times 2x is a 4x, okay? And then we have a 3x minus 1 to the power of a half times another 3x minus 1 to the power of a half, which, if you just think of that, that's just a half plus a half, which is 1. So actually we're just left with 3x minus 1. And now this is all over that 2, but I'm going to change it now to the square root of 3x minus 1. You can leave it however you want. I'll just change it back. We're not going to do anything else with that. And now if we just expand and simplify out the top, well, we have a 3x squared. That will be plus a 12x squared because we have the 4x times the 3x. So that will be a 12x squared. So that will be a 15x squared. And then we get a 4x times a minus 1. So that's a minus 4x. And this will all be over 2 and then the square root of 3x minus 1. So for this question, we have y is equal to e to the power 4x sine squared 3x, and we need to show that dy over dx equals e to the power 4x sine 3x, where we have in brackets a cos 3x plus b sine 3x, and a and b are constants to be found, okay? So again, we can differentiate this using the product rule. So if we start this, well, instead of using y, I'm going to write f of x. You can use y, and then you can have u's and b's. It's really up to you how you want to do this. I prefer writing it in the function notation. So I'm going to do f of x is equal to e to the 4x. And instead of writing sine squared at 3x, I'm going to write it as sine 3x all squared, okay? So now that we have this, well, we can let g of x can be e to the 4x, and h of x, that can be sine 3x squared, okay? So now if we differentiate this, well, we get g dash x, that would just be a 4e to the 4x, okay? H dash x is a bit more tricky. But with h dash x, well, if we think about, we can use a chain rule as well to differentiate this. So I'm going to do the chain rule, but just in my head. So for this one, we know that, okay, with that sine 3x, okay, if we were to differentiate that, we'd get a 3 cos 3x, okay? So because we get a 3 cos 3x, we know that a 3 cos 3x would come out of that. But then we'll also have this power by 2, so that's going to go down to the front and be times by whatever we have. Because we have a 3 cos 3x, that will end up being a 6 cos 3x, okay? And then also, whatever was originally in the brackets, that will also be there as well. So that will be also have a sine 3x, okay? So we know that sine 3x all squared is 6 cos 3x sine 3x, okay? And now again, using the product rule, we know that f dash x, that will be equal to g of x times h dash x. So in this case, that would be e to the power 4x times by 6 cos 3x sine 3x. If we put it all together, we get a 6 e to the 4x, and then we get a cos 3x sine 3x, and then that is plus g dash x h of x, which would be a 4e to the 4x, then in brackets would have a sine 3x squared. But instead, I'm going to write that as sine 3x because it will be easier when we get onto this next bit. So if we look at the question, we have e to the power 4x sine 3x, that is outside the brackets, so that means that we probably should factorize by that. So if we do that, therefore we'll have e to the 4x sine 3x outside the brackets, and if we factorize by that, well, if we look at the first one, we would have a 6 cos 3x, and then for that second one, a 4 sine 3x, and that is in the form we want, where a is equal to 6 and b would be equal to 4. For this question, we need to find the value of dy over dx at the point where x is equal to 1 on the curve of equation of y is equal to x to the power 5 times by the square root of 10x plus 6. So first things first, I'm going to write this in the function notation. So if I do that, that will be f of x is equal to x to the power 5, and I'm going to rewrite that square root as 10x plus 6 to the power of a half, okay? Now that I've done that, now what would g of x be? Well, we can let g of x, that can be x to the power 5, and then h of x, that can be 10x plus 6 to the power of a half. So g dash x, we differentiate that, that'll be 5x to the power of 4. And then h dash x, that would be, well, we'd get a 10. That'll come out of the brackets. And then also that half would times by a half. So 10 times a half is a 5. And then we still have our brackets of 10x plus 6. And that power would change by 1. So that would be minus a half. Okay? And now all we need to do is if we write f dash x, well, we know that's going to be g of x times h dash x. So that will be x to the power 5 times by that 5, and then that 10x plus 6 to the power minus a half, which will give us we do an equal sign, that will give us a 5x to the power 5, and in brackets 10x plus 6 to the power of a half, and that will be plus g dash x times h of x. So that will be a 5x to the power of a 4, and then a 10x plus 6 to the power of a half. Okay, and if I just rewrite this, that would give me a 5x to the power of 5, and that would be over the square root of 10x plus 6. I'm just rewriting back in this form, so when we put in our value of x later, it will just be a bit easier to solve. And that will be a 5x to the power 4 times by the square root of 10x plus 6. Okay, so now if I scroll up, now we know that we want to find the value of dy over dx when x is equal to 1. So now just plug in the value of 1. So if we do that, well, we'd get a 5 times 1 to the power 5, which is just a 5. And then that is over the square root of 16, plus another 5, and then times by the square root of 16. And if you work this out, well, you'd get 5 over the square root of 16 is just 5 over 4. And then we would get a 5 times by the square root of 16 is just 5 times 4, so that would be a 20. And then that's 5 over 4 plus 20, not 20, plus 80 over 4. And if we work that out, that will give you 85 over 4. Or if you want to write in decimal form, that would just be 21.25. So that was a quick little lesson going over the product rule. Next lesson, we'll go over the quotient rule. So I hope you enjoyed this little lesson, and I will see you on the next.